We now consider rules for combining measured numbers. Suppose you live in a city with a population of 300,000. One day, your best friend moves to town to share an apartment with you. What is the population of your city now? You might be tempted to add your friend to the city's population, in which case the new population would be 300,001. However, the number 300,000 has only one significant digit, implying that the population is known only to the nearest 100,000 people. The last 1 in 300,001 makes all the digits in this number significant, implying that it is an exact population. Your friend's move cannot suddenly tell us the exact population when we knew it only to the nearest 100,000 before, so in this case, adding the 1 is wrong. More specifically, we still know the population only to the nearest 100,000, so the correct answer when we add 1 is still 300,000. As this example illustrates, we must be very careful when we combine measured numbers. Otherwise, we can end up implying that we know numbers more precisely than we actually do. Fortunately, while more detailed analysis is sometimes needed, in most cases, you can apply two simple rules. For addition or subtraction, we round the answer to the precision of the least precise number in the problem. In our population example, the first number was precise only to the nearest 100,000, while the second was precise to the nearest 1. Since the first number is the least precise, the answer must have the same precision of the nearest 100,000. For multiplication or division, we count the number of significant digits in each measurement in the problem, then give the answer with as many significant digits as the number with the fewest. For example, the space station orbits Earth about every 1.5 hours, with each orbit covering a distance of about 42,200 kilometers. To find its average speed, we divide the 42,200 kilometers by the 1.5 hours. If you do this on your calculator, the screen will show this long number. But it would be wrong to write this number as the answer, because we really haven't figured out the station's speed to the nearest 100,000th of a kilometer per hour. Note that the distance of 42,200 kilometers has 3 significant digits, while the time of 1.5 hours has 2 significant digits. The fewest number of significant digits is 2, so the rule tells us to round the answer to 2 significant digits. Therefore, the correct answer is 28,000 kilometers per hour. There are 2 important caveats to keep in mind. First, if you are doing a multi-step problem, it's very important that you don't do the rounding until the final step. That is, keep all the digits your calculator gives you until the very end of the calculation, and only round the final answer, according to our rules, at the very end. Second, remember that these rules apply only to measured numbers, not to exact numbers. For example, the diameter of a circle is defined to be exactly 2 times its radius, a fact usually written like this. Although the 2 looks like it has only one significant digit, it is actually an exact number, not one that has been measured. Therefore, you would ignore the 2 when deciding how many significant digits belong in the answer, and just give the diameter with the same number of significant digits as the radius.